All right, so we are going to have a break soon, but before the break, I just wanted to quickly introduce this package and get a few things out of the way. So if you now open up this day 2, number 2 behavior R markdown file, and you have successfully updated your bSims package, you should be able to load this. My computer is a bit slow today. So if you spend a few seconds admiring the package startup messages, there's a lot coming from this deldir function, our package, but also bSims is giving you, I see, 2 we. You might see something else because this package startup message includes a random bird vocalization. It's all silent, but still you can read it and enjoy the tweet of the day. So when we get to simulations, then as we discussed, you have these different layers. So you can initialize a landscape with a certain extent. And here I'm jumping ahead again. I say there is a road, there is an edge around the road, and then you populate this landscape with some density, and this means in the forest, in the edge, and on the road, there is 1, 1, and 0 individuals per unit area. Then we are going to animate these with some vocal and movement rate and tell the package how far they should move around their nests. And then we put in an observer and see this is our parameter describing how quickly the detection curve drops down. And then we are going to transcribe all these into time and distance intervals as 3, 5, 10 minutes and 50, 100, and 150 meter. So if I run this, then I see simulation happening, and then I get some tables, and one of the table is called the removal table, where we see the cumulative number of individuals. And then we also have a multiple visits table that I'm not going to spend a lot of time explaining now. And then also here is an output of the different steps. So we initialize the landscape, we put in individuals, those individuals started to move and vocalize. Then we had an observer, and these spider web things are now looking at the detections. And then once we have the distance bands and this line indicates the times, then this is how we get the data transcribed in this little table. And then you can see the different colors, the green, the orangish, and the gray as habitat, edge, and the road. So there's a bit of description about the landscape, the population, and then nothing more, because we are going to work with the movement and vocalization behavior. So now it is your chance for the remaining 6 minutes before the break, and maybe over the break as well, to start running this Shiny app. And this is a version where we don't have a road inside the forest. So we only have a landscape that is a single habitat. We can increase density or decrease density. We can change the spatial pattern, keep it random, make it more regular, and then maybe clustered. Then you can look at the behavior. So these on the top are going to refer to these verbs, the simulation layers. And you can say, oh, there might be different groups. We are going to talk about this movement rate and the movement kernel. Now all of a sudden they start moving around. If you increase it large enough, then maybe these are your mammals. These are more like the little birds. And then you can show the tessellation around the nests, and then you can also allow their movement to overlap. You can say, no, you should stay inside your little polygon. So you can restrict their movement. And this initial location is just, there's no movement, so that we can better have a look at the detectability, which won't happen today. And then if you want to run ahead, then you can look at the detectability. If you increase these detection parameters, how you all of a sudden detect more and more birds, how you can change the distance function. And you can see the distance function here, how you can have different shapes. Half normal is mostly what we are going to talk about. And then on this page, you see what kind of distances and time intervals we are using to put the individuals into. There's also a way to under or over count. And then we also see our estimates for this rate parameter, which is defining availability, for the tau parameter, which is related to detectability, and then our density, which was 1.5-ish, and then this is what we estimate after accounting for these two processes. So this kind of gives you an idea about, based on one survey, what can we do? Oftentimes, our total counts are not 24. So we are not going to detect this many individuals at the same, like within a single survey. And what we do in reality is replicate these surveys, which is something we are going to come back and at the end of today, how to do that within this framework. So I'll let you to play with it and have a break, and see you back in 5 to 10 minutes. I'm going to mute myself here. And are there any questions before I go?
I had a really quick question, Peter. So is this, would we basically run this bSims for all species that we might be detecting and kind of input these vocal rates and movement rates from literature, or how would we kind of build this out?
So today we are going to use it to see how what those quantities that we talk about translate to the data that we are looking at, how to make that connection. But outside of the workshop, how this package would be useful, one way of it is certainly parameterize it based on real data, and then just tweak things like overcounting, undercounting is something we are going to look at today, and how that might bias your results. And then you can start thinking about, how do I figure out whether there is overcounting happening in reality? So how good my data is. And so kind of also brings up a lot of questions that you haven't thought before, at least when I'm playing with it and thinking about why is it happening. Then I start thinking about, okay, now I know why it's happening. Now I want to know whether this is happening in my data, or this is really a problem that I should be worried about.
Peter, could this be useful at the time of designing a study from scratch? So if you know your target species, you can come in here and say, okay, so look at the literature to see what would be a decent range of the parameters, or likely.
Yes, I would say.
Okay, how many surveys would I need? For how long should I survey to have certain power to detect a change in occupancy or an abundance of?
Yes, certainly I would say it could be useful, although no one has done it yet. So, I mean, once someone does it, then you will see really how useful this becomes. The only limitation I would think when it comes to survey design at this point is that you need to think about more than just one species. And then that means these runs are going to be independent. However, when you are in the field detecting individuals, then how abundant they are might influence how you are going to put them down, or kind of just marking those, which might be different if you are looking at like recordings. So there are these changes, and for multi-species context, I haven't put a lot of thought into how to do that other than treating the species as independent. So that's the only caveat I have there. But yes, for single species, or just, oh, this is my average species, that is certainly a useful thing if you want to kind of optimize your survey design.